Good morning to doctor. My name is Yoong Kah Hao, and today I'm going to do the introduction on the line integral. So, what is line integral? The line integral is the integral of some function along the curve. In the line integral, there are two ways to integrate the curve, which is the scalar line integral and vector line integral. The difference between these two is the scalar line integral integrates scalar value function along the curve, while the vector line integrals integrate vector value function along the curve. Before we know about the line integral, we need to know about the simple integral. To calculate the area under the graph from point A to point B, we use the small change of x, which is the dx, and multiply the height of it, which is the fx, and then we can get the formula area under the graph. For line integral, we need to transfer from 2-dimensional to 3-dimensional. First, we need to find the ds, which is the small change in arc length, and multiply the height of it, which is the fxy, from point A to point B. Then we can get the area of it. Then we use the Pythagorean theorem, which the change of arc length is equal to small change of x plus small change of y. And then we simplify the equation and you can get it ds equal to square root dx squared plus dy squared. And then we find it in terms of t. So we can get this formula. After that, we substitute the ds into the formula, and then we can get the formula on this. So, when there is not only xy plane but varies the z direction, we can find that the ds is equal to dx squared plus dy squared plus dz squared, which is dz squared is the small change of z direction. After that, we find it in terms of t, and then we substitute the ds, and then we can get the final integral. That's all from me. Thank you.
Good morning to the teacher and my fellow friends. My name is Soh Teck Wei, and today I want to discuss about the example with a complete solution regarding line integral. So this is our example. Evaluate the line integral integration y ds is the semicircle x squared plus y squared equal to 4 from the minus 2 0 to 2 0. Then step 1, we need to define some vector and the first derivative of the vector. So the vector is minus 2 cos t and the 2 sin t, and the t is between 0 and the pi because it is a semicircle, and we differentiate the vector and we will find the 2 sin t and the 2 cos t. Step 2, we need to find the ds. So refer from the introduction, then we will get this formula and we derive it to find the ds. Then finally we will get ds equal to 2 dt. And step 3 is substitution and find the error. So refer from the introduction, the error equation is this. Then we substitute in the formula, and we know the y equal to 2 sin t, and the magnitude of first derivative of the vector is 2. Then we substitute inside, and finally we will get this formula. And we're using the integration to find the answer, and the final answer is 8. Thank you. That's all.
Good afternoon, madam. My name is Jing, and I'm from Group M. And now I'm going to discuss about the first application of line integral. So in real life or in physics, line integrals are used in particular for computation of magnetic field around a conductor by using Ampere's law. So in classical electromagnetism theory, Ampere's circuitous law relates the integrated magnetic field around a closed loop to the electric current passing through the loop. So next, let's see how the line integral relates to the Ampere's law. So by referring to the figure 1 below, we can see that in this closed path contrast C, so we can see that a lot of current flowing through this area bounded by the contrast C. So the line integral of a magnetic field B around a closed path C is equal to the total current flowing through the area bounded by this contrast C. So next, This is expressed by the formula integration of the magnetic field B equals to the mu naught I, where the mu naught is the vacuum permeability constant equals to 1.26 times 10 to the power negative 6 Henry per meter. So here is an example question of using line integral in Ampere's law. So the question asks us to find the magnetic field in vacuum a distance r from the axis of a long straight wire carrying current I. So here is a solution. To find the field a distance r from the wire, we consider loop of radius r centered on the wire with its plane perpendicular to the wire with the current I as shown as figure 2 below. So since the field B has a constant magnitude and the field is tangent to the loop everywhere, the dot product of the vectors B and dr is just B times dr. Then we can write in the way as shown as below. So as a result, we have 2 pi rb equals to mu naught I, or B equals to mu naught I divided by 2 pi r. So that's all for me. Thank you so much.
My name is Hiew Rui Wen, and I'm going to present for second application of line integral calculation of mass and center of mass of wire. So let's move on. So this is a calculation for mass of wire, and this is a general formula. This is mass and integration of density and vector velocity vector. So let's go. Okay, so from the vector function rt equals to ft y t z t, this one is actually the line or the curve of the wire we want to calculate. So mass equals to integration of bounded region or bounded limit times with density and times with velocity vector, is which you can get from this one, differentiation of x over t square and square root the total. This one is magnitude of velocity vector. And let's move to center of mass of wire, and what we have to do is get the coordinate y bar and z bar. So to get this, we have to find the moment of yz divided by m. So m is what we get from the previous slide, and the moment we have to calculate using this. But for moment of yz, we have to times with x and density and velocity vector. So then we can get the coordinate of the mass of wire, center mass of wire. So that's all, and thank you.